About one important topics of matrix space, which is basis. Now also write one important result in matrix space. In a matrix space XD, a set U be open if and only if it is the union of family of open balls. Okay. Now we're going to further discussion of. Here, consider this collection. Collection contains what? Some open balls around X. Okay, X belongs to X and N belongs to this natural number. Okay, this B be a collection, that collection of open balls. Now we also write here a set U is open, then U it is the union of members of B. Obviously we talk about it. U be open, and if and only if it is the union of members of B. Union of members of script B. Okay. Then what we get? We also get it is the union of members of B. Collection has union of collection. Then this collection has the following properties. X is the union of members of B. Okay. And if U subset of X. Okay. Then X open, and obviously B1 B2 belongs to B. Their intersection is the union of a class of members of B. Okay. Then these properties are follows. So which properties are follows we here? We write this one now. Then the collection beta has the following properties. Okay, these properties are what? First we talk about X is the union of members of B. Union of members of script B. And second one is the given B1 B2 belongs to the script B. Their intersection B1 intersection B2 is the union of a class of members of script B. Okay. Then we also going to discussion of another property. If X equal to R, then which is obviously, if we talk about in this way. Okay, it is that portion, and going to further discussion of that. If X equal to R, then what? Then obviously we're going to discussion of that R difference 1 by n, R plus 1 by n, where R greater than 0 or belongs to Q and n belongs to n. Okay. Then this collection which is countable collection also, and this collection also, if R is open, then it is the union of family of members from this collection. Okay, or from this class. Now we're going to the definition of basis. Okay, we write this definition now. Let X be a matrix space. Let X be a matrix space. Okay, we write it bracket, because if X is any page, then that is not a problem, but we write this one now. Okay, in this way now. A family Then a family of open sets, a family of open sets script b equal to those vi where I belongs to this index set. Okay, and obviously this one is a basis for where I be an index set. This one be a basis of x. Okay, be a basis for the topology on x, for the topology on x. Okay, if the following condition satisfies, if the following conditions satisfies, this condition are that any open set in x, any open set in x is the union of some collection, is the union of some collection of members of this script b, members of script b. Okay, that means any open set obviously union of some members of script b. Okay, then we call this collection or family of open set the script b be a basis for the topology on x. Okay, now we going to further discussion of that. Also write this definition. Now we now talk about one important proposition. We just write it now. If script b be a basis for the topology, if script b be a basis for the topology, then what happened? If and only if and only if given x in an open set u, in an open set u, we find I belongs to I such that x belongs to bi subset of u. Okay, I have to prove this portion. If beta is basis, then given x in an open set u, obviously we find some bi subset of u. How we prove this one? Also is a portion and going to further discussion of that. Okay, obviously we also use the definition of basis. Okay, that means definition of basis is what? Any open set represent as the union of some collection from this script. Okay, so we first write this one, this collection here bi I belongs to I. Okay, this collection, then obviously we choose here an open set u equal to what? Union of bi. Okay, then union of I belongs to I, this one. Then this implies if let x belongs to u, implies that x belongs to union of I belongs to I bi. This implies that x belongs to bi, at least one I belongs to I. Okay, then what happened? Obviously this bi, obviously this bi subset of u, so x belongs to bi subset of u. Okay, that means if b be a basis, then this one is happen. Okay, but now on reverse, that means if we find let x belongs to u such that x belongs to pi subset of u. Okay, then what happened? Then since x is arbitrary, since x be arbitrary, so 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 u is the collection of pi, union of pi, because if y belongs to u, then y belongs to bk. In this way, any element obviously belongs to some set, then this u must be written as in this way, union of pi. Okay, then we also write this this script be a basis for u. Okay, or for the topology. And obviously u is the union of some collection of bi, then this one is a basis for this topology. Okay, now we also going to, that means if we write here more, that means since x is arbitrary, so we choose x from open set u, we get one bi. Okay, then x is an interior point of u and u be open set, bi be open set, then obviously one open set is collection of some open so union of some open sets. In that means this one is the in matrix space hold, we also write this one, then this one is beta, then obviously u be the collection of open sets. Okay, now we're going to discussion of another that means questions about this basis. Okay, also it is that portion. If we write to them more, then since if x is arbitrary, so u is open, then here what here x be an interior point of bi is open, then obviously you there's some open set u, some open set we write here, some open set u must be collection union of collection of opens, must be union of collection of open sets bi. Okay, in this way we write, and going to further discussion of that. Okay, then not a problem at all. We now erase that portion and going to further discussion of another problem on basis. Okay, then this problem is here, we write this one in this way, let x be a matrix space, let x be a matrix space. Okay, and d subset of x, and d subset of x, then b script b be a basis, script b be a basis for the topology on x, for the topology on x, then d is dense in x. Okay, if and only if d intersection b not equal to 5. Okay, for every b belong to this script b. Okay, also discuss this problem, that means problem. Okay, one of the important problem, I think. Also prove this problem now. Okay, there is certain disturbance also created by someone. Also, not this one is visible properly. How this one happened, I don't know. And why this was happened, we also don't know. I don't know this one mistake of myself or some. Oh, this one also not clear now. Oof. Why they are create obstacle, I don't know. They are obviously one type of poor thinkers is here. I think now proceed for proof. Okay, or establish this formula. Now given that t dense in X, then what we have to prove? We have to prove D intersection B is equal to phi. Well, obviously D intersection B not equal to phi. We do it mistake, not equal to phi. Okay, then how this one will happen? D is dense in X means we know about from this definition of dense there exists open set B, okay, such that D intersection B subset of X such that D intersection B not equal to phi. Okay, so since B arbitrary open set in X, then what happened? Then D intersection B not equal to phi for every B belongs to this basis or this collection. Okay, since B this collection equal to what? Union of this B. Okay, sorry, this collection equal to not this X equal to what? Union of this B. Okay, then obviously any B, that means D intersection this is not equal to phi. Now we going to further discussion of that. If D intersection B not equal to phi, okay, for every B belongs to this script B, then obviously B be a basis for the topology on X, then D open. Okay, then some open set B, then since B be open set in X and D intersection B not equal to phi, this means what? We let it be equal to BXR, then D intersection BXR not equal to phi, then this implies where X belongs to it, then this implies X B tends, sorry, since X is arbitrary, then this implies what? This implies dv dens in what? dv dens in x. Okay, since x is arbitrary, since x be arbitrary point on x. Okay, so this one is done. That means some open set we write it, that means some open ball in this way. Okay, so this one, this intersection bx not equal to phi, this implies d is dense in R since x is arbitrary point on x. So this one is done. D is dense means D intersection B, that means some basis element. Okay, some open set, and obviously this open set is represent some basis element. Okay, then we're going to further discussion of another problem related to this basis. We erase this portion and going to further discussion of another problem. Okay, further discussion of another problem. This problem is here. Let xy be matrix spaces. Let xy be matrix spaces. Consider the family of open sets of the form. Consider the family of open sets of the form here B x epsilon cross b y epsilon such that xy belongs to x cross y and epsilon greater than 0. Then we have to show that this is a basis for the topology induced by the product matrix on xy. Okay, then we have to show that what, this is a basis for the topology. This is a basis for the topology induced by the product matrix on xy. Induced by the product matrix on xy. Okay, then what we write now, we just write here bxy epsilon equal to what? B x epsilon cross by epsilon. Okay, bx epsilon equal to what? X difference epsilon plus x plus epsilon, and by epsilon equal to what? Y difference epsilon y plus epsilon. Okay, then how we represent this collection? Okay, this is a basis for the topology induced by the product matrix on xy. So simply we talk about in this way. Okay, let xy belongs to x cross y be arbitrary point, then xy belongs to bx epsilon cross by epsilon equal to bxy epsilon. Okay, subset of what? Subset of x cross y. Then since xy be arbitrary point and in x cross y, so x cross y equal to union of bxy epsilon. Okay, then what happened this one? Then obviously this open set. Okay, then obviously this open set, that means b x epsilon cross by epsilon, such that xy belongs to x cross y epsilon greater than 0 be a basis for x cross y. Okay, now we also today we discuss, that means some important property of open set in matrix space. That means open set is denoted by union of some open balls or some open set. Let's rewrite or known this definition of basis, and obviously certain property of basis, and obviously some example of basis. Okay, so today stop here.